Hello, class 10th physics, chapter light, application based problems. Radius of curvature of a spherical mirror is 20 meters. So here spherical mirror term is used. It can be convex, it can be concave. So we are not going into that. Find focal length. So there is a relation between focal length and radius of curvature, f equal to r by 2, and hence 20 by 2, that is 10 centimeter. Name a mirror that can give an erect enlarged image of an object. Remember, erect image. All the three mirror, plane, convex and concave produce erect image. Convex always produces, concave produces in one case, and plane mirror also produces. Okay, so this is the one thing. But they are asking about erect and enlarged image. So enlarged image is produced by concave mirror. In that case, when object is in between pole and focus. So the answer is concave mirror. Name a mirror that can always produce erect and smaller image. That is convex mirror. Erect image and smaller always. Name the mirrors that can always produce erect and same sized image. That is plane mirror. Why do we prefer convex mirror as a rear view mirror in vehicles? So first thing, convex always produce erect and smaller image. Number two, it covers wider angle, wider area. In fact, third point I'm including here in second. Wider area and relatively smaller size of mirror is required. Relatively means in comparison to other mirrors. Why do dentists use concave mirror for teeth examining purpose? The answer is, while examining inside mouth, dentist uses dentist use concave mirror. In that mode of image formation in which object is in between pole and focus, so produce larger image. Next, state the advantage of using concave mirror over plane mirror for shaving purpose. Well, I don't think you people have seen this commonly, because in our household, even me don't use that concave mirror for shaving purpose, but still it is used. So the same reason, when object is placed between pole and focus of a concave mirror, it produces larger image. For shaving purpose, uh, this effect is more useful. So concave can provide larger image and plane mirror can't. So that is why we prefer that concave mirror for shaving purpose, because it just magnifies the image, so we can see whether the area is perfectly shaved or not. Find focal length of a concave mirror. Okay, now remember, whose radius of curvature is 30. So directly f equal to r by 2, this is the formula. But remember, for r you have to write minus 30 by 2. Why minus? Because of concave. Concave has focal length negative, so that is why. In fact, radius also, radius is negative, that is why focal length is negative. So minus 15 centimeter. Name the type of all right, so there was some mistake of exposure area. Anyway, I hope you people have got this. All right, name the type of mirror used in solar furnace. So solar furnace are like solar cookers, but more focused, more concentrated. So in solar cookers, plane mirror is used, but if we replace plane mirror with the concave mirror, then it becomes solar furnace, because at its focus all the rays get concentrated. So the answer is concave mirror. Okay, which mirror can have m equal to plus 1? So plus 1 means object and image both are of same size, and virtual image, so which is provided by plane mirror. Direct answer is plane mirror. So once again, because of that focusing problem, I want to remind you, this one we have covered, but still, so dentists use that concave mirror to examine inside the mouth, just to get larger image, because concave produces larger image. And the same reason is for shaving purpose, the preference of concave mirror over plane mirror, because concave mirror produces larger image under one condition, but it produces larger image and erect image. Okay, three materials: air, water, and crown glass. Type of glass is this. Have refractive indices 1.003, 1.33, 1.52 respectively. Which one is having optically highest density? So actually, mm, the more refractive index, and the material with more refractive index has highest optical density. So crown glass, crown glass has highest optical density, as it has greatest refractive index among given materials. Next, in which among the above given media speed of light is slowest? So the medium in which has greatest refractive index will have slowest refractive index, no, slowest light. So remember, if I use eta symbol for refractive index, or in fact n might be better for you students in class 10th. So if n is large, means refractive index is large, so speed will be slower. So again, crown glass. So in crown glass, well, actually they haven't asked for the explanation. So first one, you can directly write crown glass, that's all. Here you can directly write crown glass. What is the speed of light in glass having refractive index? This one. So uh, refractive index is equal to speed of light in vacuum to speed of light in medium. And just a slight rearrangement, what we will get, v equal to c by n. It will go here and it will come here. So I hope this is a fundamental mathematical trick, so not to be get confused with it. Or if you have some other habit of this calculation, go for it. 1.50, 0 is not required, so 1.5, I'm leaving it till here. So 1.52 is 3. Oh, 1.52 is 3. That's all. And next, speed of light in a medium is 1.5 in 10 to the power 8 meter per second. Find refractive index. So directly we can do this. So 3 into 10 to the power 8 upon 1.5 into 10 to the power 8 this will get cancelled, and 1.5 2s are 3. That's all. Refractive index has no unit this time because it was velocity after cross multiplying. So it is looking like 9, it is 2 actually. So here you will have unit because we were obtaining v, but here we are obtaining refractive index n, which is unitless because speed upon speed. The refractive index of diamond is 2.42. What is the meaning of this statement? So in a very simple manner we can say that it means, okay, one thing, refractive index equal to c by v. It means c by v equal to 2.42. It means the ratio of speed of light in vacuum to in diamond is 2.42. Some people can also write that speed of light is 2.42 times greater in vacuum than in diamond. So there are many methods to express this. What is meant by 1 diopter power of lens? So 1 diopter power is the converging or diverging ability of a lens of focal length 1 meter. You can directly write this 1 diopter power is the power of lens having focal length 1 meter. But yeah, this can also be the answer. This is more accurate, but both are you will get full marks. And of course this question carries 1 mark only. Find the power of concave lens of focal length 2 meter. So f equal to minus 2 meter. Why minus? Because it is concave. So power of lens is 1 upon f is 1 upon minus 2 is 0.5 when you will divide diopter. Focal length of a convex lens is 15 centimeter. Find its power. So once again, f equal to 15 centimeter. First we have to convert this into meter. In earlier problem it was given in meter. So 15 upon 100, now it is in meter. So its power will be 1 upon f. So that is 1 upon 15 upon 100. And it will be 100 upon 15. And this will be approximately 6.67. So round off, we'll do rounding off 6.7 diopter. Okay, power of a lens is minus 2 diopter. Find focal length. So as we say p equal to 1 upon f, so also f equal to 1 upon p, and it will be minus, alright, minus I will put with value, and later on it will be minus 0.5 meter. Remember, when we convert from diopter, then it will come out to be in meter. An object is placed 5 centimeter away from a convex mirror of radius of curvature. Okay, so first we will find focal length r by 2, that is 40 by 2, that is 20 centimeter. Find position, nature and size. Position and nature of image. Okay, so u equal to, remember u is always negative. Well, right now we are mugging this thing up, but I will upload another video explaining why u is taken always negative, why for convex mirror focal length is positive, and why for concave mirror focal length is always negative. But here I will give you a briefing for that. So what happens, generally we put mirror in such a way its pole lies at this origin. So and generally we take object on left side. So all the distances, because now light will incident this way, so all the distances against the light will be taken as negative, and all the distances in the direction of light will be taken as positive. So that is why if object we are placing in this side, so all the distances will be negative. So object distance is always negative then. So now we will apply the formula 1 upon f equal to 1 upon v. Remember, it is mirror. Always keep this thing in mind. This is mirror, this is mirror, this is mirror. There are two formulae, two equations, 1 upon f equal to 1 upon v plus 1 upon u. This is for mirror, and for lens 1 upon f equal to 1 upon v minus 1 upon u. So make sure that what you are going to do, this is for mirror. So first focus yourself, first just introspect, just discuss with yourself that whether I'm doing it correctly or not. So keep the equation here. Don't try to do it fast. Just think about it. Think about it and be very, very confident. Think about it deeply and then only put the formula. Don't try to do it fast. In this chapter, in chapter light, these numerical, especially lens formula and mirror formula based problems, student often um, do this mistake. They write entirely wrong formula. For mirror they use lens formula, and for lens they use mirror formula, and if they do the mistake in the beginning, they will not awarded even half of the mark. So now just ensure the time. I have also given so much time, and you should also give so much time for these type of questions. So okay, next we'll put the values. So I'm doing directly in below it, and then I will do it later part here as required. So 1 upon 20 is equal to 1 upon v we require, and plus 1 upon minus 5. Those who are very good, they just in the same step they cover these things up, but I'm not doing that in this step. It is time consuming, but I am using other step. And now this 1 by 5 will take it on other side, so it will be 1 by v, and it is 1 by 20 plus 1 by 5. And now we'll take LCM for that. 20 common denominator, 21 plus this mathematical part, arithmetic part, I'm not going to explain. So if you still have some problem, okay, now I can switch it here and this one here. So if you have any problem in it, you can ask your maths teacher or some elder to explain you that. Even some student from junior classes, these questions are common for them. It is not something that they will laugh at you. No, it's okay to study from them. All right, so here v is 4 centimeter. Now see, my criteria to know about the nature. Just we have to calculate m. Well, this is my criteria. This is my criteria to tell about the nature. So from here we can tell about the nature, but one more step we will be sure about it. So m is minus. Remember, for lenses it is just plus v upon u, but for mirror it is minus v upon u. So minus 4 upon, and u is minus 5. This is the negative of the formula. V was having positive sign and u negative sign. So negative negative will get cancelled. So it will be a positive 4 by 5. First thing, it is less than 1. Second thing, it is positive. M is positive. So image is virtual. Remember this thing. For lens, for mirror, if final M is positive, then it is virtual image, and if it is negative, then it is the real image. And its value is less than 1. M is less than 1. Here I'm writing. So image is smaller. Next, okay, a convex mirror of focal length 1.5 meter produces an image at a distance. All right, now this is something interesting, because I have told you that for f for convex, either mirror or lens is positive, and for concave it is negative, and for distance u is always negative. But v depends upon the condition. For v you must require the knowledge of image formation, and just we have to do it by our thinking only. So here convex mirror focal length is 1.5 meter. It produces an image at a distance v is given this time. Now what will be there, minus v or plus v? So remember, in convex mirror image formation, there is only a single case in front of mirror and nothing else, because all the points are behind the mirror. So that is why whenever an image is formed by convex mirror, it will always be always behind the mirror, means on right side, and as I told you here, on right side it will be positive only. So this is how, as I explained you people, you can explain yourself. Even this diagram you can draw, you will get marks for that. If any error comes, then you will be awarded marks for that diagram. So it will be 15 by 13 meter positive. It's not required, but why I'm doing it, so in order to ensure that it wasn't negative. And now 1 upon f equal to 1 upon v plus 1 upon u, and now we will put the value 1 upon 1.5 equal to 1 upon v plus, oh sorry, v is this, so 1 upon 15 upon 13 and plus 1 upon u. So here uh, we don't have to write minus u, because u itself consists its sign. So finally when we will get the value of u, then negative sign will automatically come. So next step, 1 upon, okay, instead of 1 upon I'm writing 10 upon 15, and you people I think know why I have done that. If you don't know, all right, so I just remove decimal from here, so put a 0 over it. So now I'm taking this here, 10 by 15 minus 13 upon 15 equal to 1 upon u, and then common denominator, so 10 minus 13 equal to 1 upon u. So 1 upon u is equal to minus 3 upon 15. So u equal to minus 15 upon 3. So u equal to minus 5 centimeter. That is what required, object distance. And in few books it is written as 5 centimeter in front of mirror. So a student often says that here u is positive, so actually this statement contains its negative. Alright, so here an object 4 centimeter long is placed, actually 4 centimeter long, but it is height of object 4 centimeter, placed 25 centimeter in front of a concave mirror of focal length. Concave it is, and mirror it is, f equal to concave, so minus 15 mirror, so we will apply mirror formula. What distance from the mirror should a screen be placed? Remember, concave mirror produces real images mostly, so real image is one in which reflected rays actually intersect and which can be obtained on screen. So this is what they are talking about, image distance. So here 20 centimeter away, so u is minus 25 centimeter. So now we will put these value into mirror formula, and remember mirror formula, it has plus in it. 1 upon minus 15 is equal to 1 upon v plus 1 upon minus 25, so that it is minus 1 by 15 equal to 1 by v minus 1 by 25. We'll take it on other side, 1 by 25 minus 1 by 15 equal to 1 by v, and 1 by v is equal to 50. So 25 twos are, oh my god, 75 actually, 75. So 3s are 25, 3s are 75, and 15 5s are. Okay, so 1 by v equal to minus 2 by 75. So v is equal to minus 75 by 2, or minus 37.5 centimeter. Alright, so that's it. This is the first part, means at a distance 37.5 in front of mirror. So, and if you leave answer here, you will get the marks, no problem with that. Now nature and size of image. So for nature, I tell you this formula. So here v is minus 37. Okay, one minus is of formula, other minus is of value of v, so be careful about it. So this is how we go. So m equal to minus v upon u, we will put the value, and this will come. It is large because m is greater than 1, so larger image is there, and it is in negative, with negative sign, so image will be real because m is negative. If m would be positive, then image nature of image would be virtual. So then we'll put the value here, and find hi, height of image. So this is that. So okay, next question. A concave mirror of focal length 20 centimeter produces an image double the size of object. Find distance of, okay, so here it is, because concave mirror two times uh, provides larger image. One, when object is in between C and F, then it produces larger image, and when object is in between pole and focus, then also it forms larger image. So here it is not mentioned that whether this image is real or virtual, because if it is real, then this case would be used, and if it is virtual, then this. And where we will put these values, because double the size means m is 2, but whether it is positive or whether it is negative, that's not clear. It can be both. From these diagram we can say. So in such a question where there is no clarity, we can take it either positive or negative. But if they would say that find possible distances, then m equal to plus 2 either, or m equal to minus 2 for virtual image, for real image. Okay, so we know that m is equal to minus v upon u, that is equal to 2. So v is equal to then minus 2u, and here this is minus v upon u equal to minus 2, that is v equal to 2u. And now we will put it here, and focal length is 20. So 1 upon 20 is equal to 1 upon minus 2u plus 1 upon u, that is minus of this. So 2u, we are not going to change something here, but here it should be multiplied by 2 on numerator and denominator. So 2, it will be equal to 1 by 2u. So if we reciprocate it, oh, there is a slight error, it is concave mirror. Okay, be very sure about it. So okay, now we reciprocate it, so it will be 2u equal to minus 20, so u equal to minus 10 centimeter. Now second case, here again the same way, 1 upon f equal to 1 upon v plus 1 upon u, 1 upon minus 20 equal to 1 upon 2u plus 1 upon u, that is 2u 1 plus 2. So it is 3 by 2u. So we'll reciprocate it, 2u by 3 equal to minus 20. So finally u equal to minus 20 into 3 by 2, that is u equal to minus 30 centimeter. Now see, this is for concave lens. So focal length is minus 15 centimeter and object is, okay, image at a distance. Now see, concave lens, at any case it always produces virtual image in front of lens, and both are on left side. So object distance is negative, which is not given here. Image distance is also negative, so v is equal to minus 10 centimeter. Now we can put this formula. It is for lens, so negative 1 upon minus 15, 1 upon minus 10, minus 1 upon u. It will go this side, it will come this side, because we have to find u. And it is minus 1 upon 10 and plus 1 upon 50. So u 1 upon u is equal to 30 minus 3 plus 2. So 1 upon u equal to minus 1 upon 30. So u equal to minus 30 centimeter. And magnification, the main question was magnification, that is v by u. Don't get confused with those mirror formula and all that. Minus 30 equal to 1 by 3. And that's all they have asked for this. If they ask for nature of image, so it is positive, so it is virtual, and we know that concave lens always produce virtual image. Next, a 2 centimeter tall object, height of object 2 centimeter, at a distance 15 centimeter of focal length. So it is convex now. Focal length is positive 10 centimeter. Find position, nature, size of image. Draw image diagram also. So first we will draw the diagram, which we can do easily. Focal length is 10. So here till here it will be 10. This is 2f. Dash actually on this side. These are dash. These are um, main focus is this. So if till here it is 10 and object is at 15, so somewhere here. So it is the case when object is in between f and 2f, then we know its image forms beyond 2f. This one. And here, final image forms. So it is larger, it is inverted and all that. So this is the first thing. So for this, we don't need any calculation. We should understand where will be the position. See, till here it is 10 and till here it will be 20. So 15 will somewhere in between them. This is just a general idea we can put here. So now 1 upon f equal to 1 upon v minus 1 upon u. So 1 upon 10 is equal to 1 upon v minus 1 upon minus 15. Minus minus will get positive. So plus 1 upon 15. So 1 upon 10 minus 1 upon 15 is equal to 1 upon v. So 1 upon v is equal to 33 minus 2. So 1 upon v is equal to 1 by 30. And it is positive on other side, 30 centimeter. And position nature. For nature, as I told you, find m. M equal to v upon u. V is 30, u is minus 15. So answer is minus 2. M is negative, so it is real. And size of image, we can say it is larger because it is greater than 1, but we can also calculate it. Hi upon ho. M is minus 2. Hi, we have to find ho. Okay, all right, there is lots of space. Anyway, so ho is 2. So hi will be minus 4 centimeter. Minus because it is inverted. So an object 5 centimeter in length, height of object 5 centimeter, held 20 centimeter away, u equal to minus 25 centimeter from converging lens. From a converging lens, so it means convex lens. So converging lens, remember converging lens is convex lens of focal length 10 centimeter. Find position, nature and size of image. So once again we will proceed accordingly. 1 upon f equal to 1 upon v minus 1 upon u. So 1 upon 10 is equal to 1 upon v have to find, and minus 1 upon minus 25, that will be plus. So 1 upon 10 equal to 1 upon v plus 1 upon 25. So 1 upon 10 minus 1 upon 25 equal to 1 upon v. So 1 upon v is equal to 55 minus 2. 1 upon v 3 by 50. So v equal to 50 by 3 centimeter. You want to find it in decimal, that will be okay. And yeah, we have to write the answer. I have just did a rounding off. It will be 16.66666. So I'm not doing that. I have rounded it off. And okay, this is position. Nature, for nature, m. M will be v by u, and v is I'm not taking this. This one is convenient. 50 by 3. Fraction will be convenient for you. Remember, it looks difficult, but it is much simpler. So minus is taken this way, and 25 twos are. So m is equal to minus 2 by 3. It is negative, negative, so real. And less than 1, so smaller image, but we can even calculate it. M in the place of m, we can put hi upon ho equal to minus 2 by 3. Hi we have to find, ho we know it is 5. So minus 2 by 3. So after cross multiplying it, hi is equal to minus 10 by 3 centimeter. Next, half of convex lens surface is covered with black paper. This lens produce image of object, yes. And how we can draw it? Because still, okay, this half portion is covered, so still it can produce this is main f, and this is f dash. So anywhere we can put, so still it will go from this side. Oh, this is 2f. So this is final image. So still it is able to form images. And same is true for if we talk about mirrors. So I'm taking the example of In fact, I can take the example of convex also, but I have seen such question for so it is painted, and now let's see. Yeah, still it can produce image. So the answer is yes, and for verification you can draw the diagram. This is not for this question, I have just made another question in one question. If asked, then you can write it. Magnification produced by a mirror is +1. What does this mean? So +1 means m is positive, so it is virtual image, virtual and erect, and m is equal to 1, that is hi upon ho, and therefore we can say hi is equal to ho, means same size, which happens in plane mirror. Name the lens and mirror which always produce real image. Answer is none. There is no mirror, no lens which always produce real image. We know convex lenses produce real image, but under one condition they produce virtual image, so no. And concave mirror always mostly produce real image, but one condition. For convex there is a condition, focus and optical center. Between focus and optical center, if object is placed, then image is virtual. And in the same way for concave mirror, if object is in between focus and pole, then image is virtual. So there is no mirror, no lens which always produce real image. So that's all. More question coming. Bye.